So, good day everyone. I am Loren J. Sinahonan and I'm going to discuss about this topic which is the three data structure. So, introduction to three. A three is a finite non-empty set of elements. So, in the context of data structures, a tree is a collection of elements organized in a hierarchical structure. So the term finite non-empty set indicates that is a limited number of elements and the sets is not devoid of content. So the second is it is an abstract model of hierarchical structure. So the term abstract model implies that a tree is conceptual representation used to understand and describe hierarchical relationships. It is not a physical tree but a way of visualizing relationship in a structured manner. So the third one is consists of nodes with a parent-child relationship. In a tree, in a tree structure, elements are represented as nodes. Each node has a parent-child relationship with other nodes. The parent node is the one higher in a hierarchy, and the child node is one lower. This hierarchical arrangement helps organize and represent relationships efficiently. So the fourth is applications organization chart. So trees are used to model organizational structures where each node represents as position or individual within an organization. So the parent-child relationship illustrates the hierarchy of positions or rule. So file systems. Three are employed to organize files and directories in computer file systems. So directories are represented as nodes, and the parent-child relationships show the hierarchy of folders and files. So the last is the programming environments. Trees are utilized in programming environments to represent the hierarchical structures of code. Abstract syntax trees, or AST, and base three self-analyze and understand the syntax and structures of programming languages. So three three terminology. The first is root node without parent A. So the root of tree is the topmost node denoted as A in this case. So it is a node does not have a parent and it serves as the starting point for hierarchical structures. So the second is siblings node share the same parents. So nodes that share the same parents are called siblings. For example, in the three structures, nodes B and C are siblings as they have the same parent, A, just the A. So the next is internal node without at least one child, A, B, C, and F. So an internal node is a node that has at least one child nodes. A, B, C, and F are internal nodes in this context. So next is external node, leaf node without children, E, I, J, K, G, H, and D. So an external node or leaf is a node without any children nodes. E, I, J, K, G, H, and D are examples of external nodes in the tree. So next is ancestors of node, parent, grandparent, grand-grandparent, etc. So the ancestors of a node are the nodes that lie on a path from the node to the root. This includes the parent, grandparent, and so on. So next is descendant of a node, child, grandchild, grand-grandchild, etc. So the descendants of a node are the nodes that lie below it in the hierarchy, including children, grandchildren, and so forth. So next is deep of a node number of ancestors. So the deep of a node is the number of ancestors it has. It is a measure of how far the node is from the root. So next is height of tree, maximum depth of any node. So the height of a tree is the maximum depth among all its nodes. So in this case, the height is given as 3. So the next is degree of a node number of each children. So the degree of a node is the number of children it has. For instance, node A has 3 children, which is B, C, and F. So its degree is 3. So the next one is degree of a 3, the maximum number of its node. So the degree of a 3 is the maximum number of children among all its nodes. It's determined by finding the node with the highest degree. Next is sub 3. 3 consisting of a node and its descendants. So a sub tree is a tree formed by a node and all its descendants, including the node itself. The next is, and the last is edge connecting lines of three. So in a tree, edges are the connecting lines between nodes representing the relationship and hierarchy in the structure. So this slide provides fundamental terms and concepts related to three structures, helping to understand, describe the properties and relationship within a tree. So three terminologies. So as we can see, we have a property and a value. So property are the numbers, nodes, height, root node, and so on, and the value is 9, 4, 8, so on. So the first is number of node is 9. So this indicates that the tree has a total of 9 nodes. So the next is height is 4. So the height of the tree is 4, representing the length of the longest path from the root A to leaf. So root node A. Root node is A. So as identified as the root node, which is the topmost node in the tree and has no parent. So the next is leaves is D, H, I, F, and Z. So the leaves of the tree, also known as external nodes, are D, H, I, F, and C. These are the nodes without any children. Interior nodes and the value is A, B, E, and G. So interior nodes are nodes within a tree that are not leaves. In this case, A, B, E, and G are interior nodes. So the next is ancestors of H. Is the value is G, E, B, and A. So the ancestors of node H are G, E, B, and A. These are nodes on the path from H to the root. The next is a descendants of B, and the value is D, F, G, E, G, H, and I. So the descendants of node B are D, F, E, G, and H, and I. These are nodes below B in the hierarchy. So next is sublinks E, and the value is F and D. So siblings are nodes that share the same parent. So in this case, the sibling of E are F and D. So the next is right subtree of A, and the value is C. So the right subtree of node A is formed by a subtree rooted at C. This indicates the portion of the tree that descends from the right child of A. So the last one is degree of these three, and the value is 3. So the degree of the 3 is the maximum number of children among all its nodes. In this instance, the maximum degree is 3. So this information collectively provides detailed overview detailed overview of the tree, including its size, structure, height, root node, leaves, interior nodes, relationships, and specific characteristics such as the right subtree and degree. So three types of three. First is general three. The general three. If no constraint rule is placed on the three hierarchy, a three is called a general three. Every node may have infinite numbers of children in general three. So the three is superset of all other threes. So a general tree is a type of tree where no specific constraint or rules is imposed the hierarchy. In this type of tree, every node may have an unlimited number of children. It is considered a superset of all other types of tree, allowing for a more flexible and arbitrary structure. So the next is a binary tree. The binary tree is the kind of tree in which most two children can be found for each parent. The kids are known as the left kid and right kid. So a binary tree is a specific type of a tree which each parent node can have the most two children's. So these children's are typically referred to as the left child and the right child. Binary trees are widely used in various applications, and their structures facilities efficient searching and sorting operations. So the third is binary tree. A binary tree or BST is a binary tree extension with several optional restrictions. So the left child value of node should be in BST or binary search tree be less than or equal to the parent value, and the right child value should always be greater than or equal to the parent value. So a binary search tree is a special type of binary tree that imposes specific restrictions on the relationships between nodes. In a BST or binary search tree, the left child of node must have a value less than or equal to the parent's value, and the right child value must be greater than or equal to the parent's value. This disordering property enables quick searching and retrieval of elements, making BST suitable for application like searching and sorting. So in summary, in General 3 allows for an arbitrary numbers of children per node without specific constraints on hierarchy. And binary tree restricts each parent node have at most two children, simplifying the structure compared to a general tree. So in binary search tree or BST in a specialized binary tree with ordering rules, making it efficient for search operations. So these types of trees serve different purposes and are applicable in various scenarios based on the specific requirements of the problem or application at hand. So binary tree. A binary tree is a tree that adheres to the following properties. Each internal node has at most two children's degree of 2. So the children of a node are an ordered pair. So the children of an internal node are specifically named the left children, child and the right child. So next is the alternative recursive. So alternatively, a binary tree can be defined in a recursive manner. So it is either a tree consisting of a single node, or it is a tree whose root has an ordered pair of children, each of which is a binary tree. So applications. Arithmetic expressions. So binary trees are commonly used to represent arithmetic expressions. In such trees, internal nodes represent operators such as addition or multiplication, and the three leaves represent operands number of variables. The three structures reflects the order of operations in the expressions. The next is decision processes. So binary trees can be used to model decisions processes. Each internal node represents a decision point, and the left and right children represent these possible outcomes or choices at the decision point. This structure is useful for decision making algorithms and scenarios. So the last one is searching. So the binary trees are employed in searching algorithms, particularly in binary search trees. In the ordering property of binary search trees facilities efficient searching and retrieval of elements. So this makes binary trees suitable for various searching application. So in summary, a binary tree is a tree structures where each internal node can have at most two children and the children are ordered as left and right. The recursive definitions allows for flexibility and representing binary trees. Application includes modeling arithmetic expressions, decisions, processes, and searching algorithms. Next is the binary tree traversal. So binary tree traversal, a tree traversal refers to the specific order in which the node R3 are visited process. So these are three common three traversals. So first is in order traversal. In order traversal, the order of visiting models is left root, and right. So for each subtree, the left branch is printed before the root, and then the right branch is printed. So this traversal is often used for binary searching trees to retrieve elements sorted in order. So the next is pre-order traversal. In pre-order traversal, the root is root left and right. So the root of each subtree is printed first, followed by the left and right branches. So this traversals is useful for creating prefix expressions in arithmetic expressions. The third is post-order traversal. In a post-order traversal, the order is left, right, root. The left and right branches for each subtree are printed first, and then the root is printed. So this traversal is commonly used in expression trees and for freeing the memory allocated to the nodes. So the last is note on pre and post. So the term pre and post and pre-order and post-order refers to when the root is visited during the traversal. And pre-order, the root is visited before the left and right branches. In post-order, the root is visited after the left and right branches. These three traversals are fundamental techniques used in a various applications, including expressions of tree, evaluation, sorting and searching algorithms, and more. So the choice of traversal depends on the specific requirements of problems or application. Binary tree traversal. So first is in order. So these are the binary three traversal examples. So first is in order with left, root, right. So the sequence is 3, 5, 6, 7, 10, 12, 13, 15, 16, 18, 20, and 23. So in order traversal, each subtree's left branches is printed before its root. So and then the right branches is printed. The result is a sorted sequence in ascending order, typical for binary search trees. The second example is pre-order, root, left, and right. So the sequence is 15, 5, 3, 12, 10, 6, 7, 13, 16, 20, 18, and 23. So in the pre-order traversal, the root of each subtree is printed first, followed by the left and the right branches. This sequence can be useful for constructing and prefix expression arithmetic. So the third is, and the last is post-order traversal, left, right, and root. And the sequence is 3, 7, 6, 10, 13, 12, 5, 18, 23, 20, 16, and 15. So in the post-order traversal, the left and right branches of each subtree are printed first, and then the root is printed. So this sequence commonly used in expression trees and for freeing memory and deletions operations. So these sequences represent the order in which the nodes of binary tree would be visited based on the specific traversal method. Understanding these traversal techniques is crucial for various applications, including tree manipulations, expressions, evaluation, and tree-based algorithms. So that's all. Thank you.